Hey everyone, welcome back. In this video, we're going to talk about some of the things that are, for lack of a better description, downstream from the garbage collection topic. Basically, how do you manage references to resources? So where garbage collection managed memory and cleaned up old instances of objects, this video will talk about how to make sure that your objects are at least minimally cleaning up after themselves. We'll start off with a little bit about what these resources even are and why this matters. While we're on that topic, we'll learn why some things in C# need special cleanup and how to handle that cleanup properly. There's this interface called IDisposable. That's like a promise that something needs cleanup. Don't worry, it's way simpler than it sounds. I'll show you exactly what it means. And here's the cool part. C# has this thing called the using statement that handles all the cleanup for you automatically. It's like having a responsible roommate who always closes the door behind them. We'll also look at what can go wrong if you forget to clean up resources. Spoiler alert, it's not pretty, but once you understand it, you'll never make this mistake. Okay, so first things first. What do we mean by resources? This confused me for months when I was starting out. Here's the thing. Not all objects in C# are created equal. Most objects, like strings or numbers, the garbage collector handles them perfectly. But some objects, they're special. When you open a file, Windows keeps track of it. If you don't close it properly, that file stays locked and nobody else can use it. Ever tried to delete a file and Windows said no? This is why. Database connections are even more precious. Most databases only allow a certain number of connections. Use them all up without releasing them, your whole application stops working. Network connections, like when you're calling a web API, keep ports open on your computer. Leave too many open and you literally run out of network resources. The IDisposable interface is one of those absolutely essential topics in C# and .NET. Whenever you see something that's hanging out in the system namespace, you can be absolutely certain that it's an important core concept in .NET. And the IDisposable interface is one of those things. This interface is used all over the place. You see it everywhere in the code for .NET itself. And in tons of apps that are written on top of .NET IDisposable has one method called dispose. Whenever you see a class that implements IDisposable, you pretty much know that this class uses some expensive resource that needs to be cleaned up and managed. Let me show you what happens when we forget to clean up. This is a super common beginner mistake. See this? We opened a file for writing but never closed it. That file is now locked by our program. Nobody else can touch it, not even our own program later on. When we try to read the same file later, boom. I/O exception. The file is still locked from our earlier write. This is so frustrating when you don't know what's happening. And here's the worst part. That file stays locked until your entire program shuts down. If this is a web application, that could be days or weeks. In C#, like in most things in software development, there are a whole bunch of ways to do stuff. If we wanted to do this manually, we could use the try finally syntax. The try block is all code you'd like to run, but it might not all entirely run if an error happens. The code in the finally block runs, even if the code in the try block throws an exception. Since this finally code always runs, it's where you'd put your resource cleanup code. In this case, it's where you'd clean up the stream writer. But it's a little tricky here because it's possible that the writer variable is null. If we call a method on a null variable, we'll get a null reference exception. Anyway, if the variable isn't null, we can run cleanup on it. The close method flushes any unwritten bytes to the file and then closes the files. Then you call dispose and that notifies the stream writer that we're done and that it can clean up anything else it might have hanging around. So this all works and it's what needs to happen. But this is also a lot of work. And that brings us to the topic of the using statement. Let's compare the manual way versus using the using statement. When we wrap something in a using statement, C# automatically calls dispose when we hit that closing brace, even if there's an error. If you do it this way, it all happens for you, and you don't have to worry about writing cleanup logic. And look how much cleaner this is. We went from 12 lines to 4 lines. Less code means fewer bugs and easier maintenance. As of C# 8, there's a new way to do this called a using declaration. This saves you from having to write a bunch of squiggle bracket blocks in your code just to set up the using statement. Just put using before the variable declaration. No extra curly braces needed. The resource gets disposed when it goes out of scope, and typically that means when the method is done. This is especially nice when you have multiple resources that need disposing. Instead of nesting using statements inside each other, they can all be at the same level. And what you end up with is much more readable code. So this gives you the same cleanup logic with fewer squiggle bracket blocks. So what things need the using statement? Here's how to know. The rule is simple. If something implements IDisposable, you should probably use using with it. IntelliSense will usually suggest it when you type new. All the file stuff, stream reader, stream writer, file stream, if you're touching files, you should almost definitely be using using. If you're doing calls against a database, not cleaning up your connections can cause serious problems. Actually, let me be a little more precise. If you're not cleaning up your connections fast enough, you can get into problems. More on this when we get to the next slide. Network stuff like HTTP client and TCP client also typically need to be cleaned up. Although, fun fact, HTTP client is special and shouldn't be created in a using statement every time. Creating too many instances of HTTP client can cause problems. That's out of scope for right now. More on that in a future video. On that last slide, I mentioned that database resources will probably ultimately get cleaned up by garbage collection, even if you forget to clean them up, but not cleaning them up fast enough can cause huge, gigantic show-stopping problems, especially in high-traffic web-based or REST-based system. If you want a high-performance web app or web service, you need to release your database connection as fast as possible. In all likelihood, this doesn't actually fully close the database connection, but it instead returns it to something called the connection pool. The pool keeps a bunch of database connections ready for use, so that each request doesn't have the performance overhead of 100% reconnecting to the database. If you don't release the connections fast enough, it's entirely possible that you can drain the pool and therefore run out of database connections. So use the connections and release them as fast as you possibly can using a using structure. Here's a little more on using blocks versus using statements. Where the using statement really shines is when you have multiple resources to manage. Let's say you have two disposable resources you need to worry about, input and output. Before the simple using statement, you had to create two squiggle bracket blocks to handle the using logic. This just gets ugly. It's a whole lot of nested using blocks, just for handling the cleanup of these resources. It's not absolutely awful when you just have 2 items to manage. But if you start getting into 3 and 4 or even 5 items to manage, then you get this weird pyramid effect as you nest all the using blocks. Using declarations keep everything flat and readable. Each resource on its own line, all at the same level. This is how code should look. Fun fact, resources get disposed in reverse order from how you declared them. Last in, first out. Usually doesn't matter, but, well, it's just a little something to know. Let me show you the #1 mistake I see beginners make with using statements. Don't return a resource from inside a using block. Once you leave the block, that resource is disposed. You're returning a dead object. I've seen people try to return a stream reader from a method with using. Nope, that reader is closed before the caller can use it. Read all the data you need inside the using block, then return the data, not the reader. Return strings, not streams. Trust me, you'll make this mistake at least once. We all have. Now you know to watch for it. Here's another gotcha, storing IDisposable objects as fields without proper cleanup. If your class has an IDisposable field, your class should also implement IDisposable. You can't just use using with fields, they live too long. When your class owns an IDisposable resource, it becomes responsible for cleaning it up. That means implementing IDisposable yourself. It's like resource management inheritance. Honestly, if you can avoid storing IDisposable objects as fields, do it. Create them, use them, dispose them all in one method. Much simpler. So what actually happens if you forget to use using? Let's talk consequences. Without proper disposal, resources leak. Files stay locked, database connections remain open, network ports don't get released. It's like leaving all the lights on in your house. The garbage collector might eventually clean things up when it finalizes the object. But that could be minutes, hours, or never. You can't count on it. I've seen production systems crash because they ran out of database connections, all because someone forgot a using statement. Actually, in the case I'm thinking of, it wasn't just forgetting one using statement, it was forgetting like 50 using statements. It totally wrecked the app. Dozens of DB connections sitting there doing nothing while the system waited for garbage collection to run. The good news? This is so easy to prevent. Just use using. Modern IDEs will even warn you if you forget. Visual Studio puts a little squiggly line under it. Let's put it all together with a real example. Reading a CSV file the right way. See how clean this is with a using declaration? The file opens, we read all the data, and it automatically closes. Done and done. Notice we're returning a list of customers, not the stream reader. We extract all the data while the file is open, then return just the data. And if there's an error, like a malformed CSV line, the file still gets closed properly. That's the beauty of using statements. They work even when stuff goes wrong. All right, let's wrap up what we learned about resource management. Not everything in C# is handled by the garbage collector. Files, database connections, network resources, they all need explicit cleanup. These resources are downstream of garbage collection. They might ultimately get taken care of by garbage collection, but that's probably not the ideal situation. Simple rule, if something implements IDisposable, wrap it in a using statement. Let C# handle the cleanup for you. Also, if you're using something that implements IDisposable and you're keeping it around as a member variable or a property value, you might want to consider implementing IDisposable on your class too. Using statements guarantee cleanup, even when errors occur. They're your safety net against resource leaks. In C# 8 and later, using declarations make your code even cleaner. Same safety, less nesting. Next time, we'll look at some structural stuff and some under-the-hood plumbing stuff in .NET, app domains and assemblies. Thanks for watching. I hope you enjoyed this video, and if you're feeling wildly motivated, please consider clicking like and subscribe. Stay tuned for more.